This is homework help video for Advanced Algebra, Lesson 4H. We're going to look at 4 problems. First being number 18, write a matrix equation based on this system of equations. What you want to do to write a matrix equation is first look how many variables you have. I see an x, a y, and a z. Those will be my columns. I'll have an x column, a y column, a z column, and I'll have 3 rows. Why 3 rows? Because I have 3 equations. So when I translate this one, my first matrix is all the coefficients of x, y, and z, and of each subsequent equation. So my first row is going to be my red equation, coefficient of x, coefficient of y, and I have 0 z's in my first equation. That's why I'm writing a 0 there. In case you have forgotten, you can always put a 1 in front of the variable, hence the 1 and the negative 1. For my second equation, it's going to be my green row, coefficients of x, y, and z again. Negative 2, negative 5, negative 6. I have all 3 variables represented in that second equation. And my third one, which will be blue, coefficient of x, coefficient of y, coefficient of z. Remember, again, I can put a 1 in front of that. If I were to take that coefficient matrix, that 3 by 3 matrix, I should be able to multiply it by the variable matrix, with all the letters in it, and get back to those 3 original equations. I take the 3 by 3 times the 3 by 1, I get my equations back. As long as I remember, I need one more matrix that has all the answers in it. By the answers, I mean the 8, the 27, and the 54. If I were to multiply the 2 matrices on the left, they would equal the matrix on the right, which is what the equation is telling me. If I go to problem number 20, it says solve. I have to find what m and n is equal to. In order to be able to solve a matrix equation like this by hand, first I have to be able to find the inverse of that matrix that I put the little green star by. In order to be able to find the matrix, the first thing you got to calculate is the determinant. Your determinant is the product of the main diagonal, 7 times 5, minus the product of the other diagonal, 2 times negative 3. I do my multiplying and my subtracting. I get a determinant of 41. When you want to find the inverse, it is the reciprocal of the determinant. So it is going to be 1/41st. And then I rearrange that 2 by 2 matrix, first by switching the positions of the main diagonal. So switching where the 5 and the 7 are, and then taking the opposite of the other diagonal. Making this a positive 3 and a negative 2. Now, depending on your instructor, some will want you to go through and perform that scalar multiplication. So I'm going to do that right now. All that's going to happen is from this inverse matrix that I'm putting the little red dot by, I'm going to multiply each of those elements by 1/41st, hence creating all of these fractions. So this red matrix in the lower left-hand corner is your inverse matrix of the original 2 by 2 matrix. So what do I do with that inverse matrix? I'm going to take that inverse in red, and I'm going to multiply it by my answer matrix. What I mean by my answer matrix is that one with the little black star by it. If I take the inverse times the answer matrix, I will then be able to figure out what m and n are equal to. So what does that entail? That entails taking the inverse matrix that I have in the lower left-hand corner, and multiplying by that 2 by 1 matrix that is my answers. Matrix multiplication is the same as it was from the beginning of the chapter. Multiply rows of the first, columns of the second. So if I do that, I'm going to multiply 5 41sts times 41 plus 3 41sts times 0, row 1 times column 1. And then row 2 times column 1, negative 2 41sts times 41 plus 7 41sts times 0. I do my multiplying and my adding. What do I end up with? I end up with a matrix with 5 as row 1, column 1, and negative 2 as row 2, column 1. Well, what does that mean as far as my answers go? I look at my variable matrix. M is in row 1, column 1. That means that's 5. N, row 2, column 1. That's the negative 2. There's my solution by hand to number 20. Number 28, basically the same problem. I'll start by translating my system of equations into a matrix equation. I have a column for my P coefficients. I have a column for my Q coefficients. If I take that times my variable matrix, that should be equal to what the answer is to each equation, or 122. Now, instead of doing this one by hand, I'm going to set it up so I could use my calculator. And what you saw in the previous problem is I want to take the inverse of the coefficient matrix, and I'm not going to do that by hand in this particular instance. I'm just going to put the symbol, the notation for the inverse. I want to take the inverse of the coefficient matrix and multiply it by what I call the answer matrix. I can put those two in my calculator, have my calculator find the inverse for me, perform the multiplication for me, and then I can have the machine tell me what P and Q is equal to on my calculator screen. Now, your teacher may not want you to do that. If you have to do it by hand, you're going to follow the same steps that you would for number 20 here at number 28. If I were to type that in my calculator, I should see that P is equal to 7 and Q is equal to 3. That's your solution for number 28. Number 32, story problem. What you have to do now is you have to create your own system of equations. From that, create your matrix equations and then solve it however your instructor is telling you to solve those matrix equations, whether by hand or by calculator. So if I look at number 32, one thing that I notice is that I have a lot of dollar values. Flight instruction costs $105 per hour. Simulator costs $45 per hour. He can afford to spend $3,870 on training. When you see dollar values over and over again in a particular problem, pretty good indication they should all go together to make a single equation. Before anything else, though, I should probably define variables. And for me, I'm going to use the variable I for instruction hours, and I'm going to use the letter S, that's supposed to be an S, for simulator hours. Now back to my equations. All those dollar values tell me they kind of all go together. Like it's $105 for every instructional hour that he uses, plus $45 for every simulator hour that he does. And that total cost of instruction and simulation cannot exceed $3,870. $870. Okay? I have one equation with two variables, so I know I need another equation. Well, the only other information they give me is in the third sentence, the school requires students to spend 4 more hours in airplane training than in the simulator. In other words, 4 more hours in instruction than in the simulator. How do I get an equation out of that? Well, here's one way to look at it. If I were to take my instruction hours, however many that may be, and subtract my simulator hours, what should that difference be? According to that sentence, the school requires students to spend 4 more hours in airplane training. That difference should be equal to 4. I now have 2 equations for my 2 unknowns. I can create my matrix, say my coefficient matrix, 1 column for i's, 1 column for s's, my variable matrix, should be equal to my dollar value and my difference in times. I now can solve this matrix equation, whatever your instructor is telling you, whether that's by hand or by calculator. By calculator again, I'm going to take the inverse of that coefficient matrix and multiply it by what I refer to as the answer matrix. Whatever I get out of that product is my solution. It will tell me my instruction hours and my simulator hours. In this particular instance, if you perform that matrix multiplication, whether by hand or by calculator, you should get instruction hours to be 27, and you should get simulator hours to be 23. You notice that there's that difference of 4 between those two values, just like the problem said there should be.